Perfect. So this talk is called General Considerations from N Years of Simulation Studies. I will give it together with Benjamin Männel, who will give the second half of this talk. And yeah, to start, just a reminder, we have the GGOS Committee on Performance Simulations and Architectural Trade-offs, called PLATO, which is chaired by myself since 1 week from EKG, which is where my slide template changed, and Benjamin Männel from GFZ. I took over from Daniela about 1 year ago. Yeah, I'm really happy that Benjamin continued to chair this group together with his experience. Currently, we have 34 individuals from approximately 17 institutions contributing, and especially around EGU this year, where we had a splinter meeting, we could also acquire about 10 new members to join our group. So it is a vivid topic which is of interest. The goal of our group is, in principle, defined that we want to improve the accuracy and stability of the global reference frames in order to fulfill the famous GGOS requirements, this 1 millimeter stability and 0.1 per year in velocity of coordinates. And the questions that we arise is how should the ground segments of the different space geodetic techniques be developed? This refers to the distribution of stations, but also to their performances. How do we have to adapt the analysis strategies? So how to process the data and how to combine the data to obtain our solutions. And the last big block is how to exploit co-locations in space. So what can we do with existing satellite missions? Do we need new dedicated satellite missions? Okay, so I am now going to talk about the first 2 of these blocks, starting with the ground segment. Some general conclusions of the various studies that we had. There is some exemplary literature on the bottom always given. We could definitely demonstrate that we have to fill gaps in the existing space geodetic networks. So the optimum location of the station can depend on various factors, especially the parameter of interest. So for the scale of the TRF, it's important to really fill the gaps, to use places where we don't have stations so far, especially in the ocean regions. For other parameters like the EOPs, we could define optimal locations, for example, in the planes of the different EOP parameters. For the pole coordinates, for example, Y pole could be improved significantly by stations in the plane 90 degrees east and west. For Earth rotation, so LOD and UT1, it would be rather in the equatorial regions. We have several specific studies which demonstrate the importance of the existing sites. For example, sites like Männel or also the Argo, now existing Argo site in South America, as well as of additional sites, especially, of course, the regions where we have gaps like Latin America, India, or also the Pacific Ocean would be valuable places to establish new sites. And not only for a single technique, as we have in the bottom block, of course, also the distribution and quality of local ties. It's really important in order to stably realize the geodetic datum of a reference frame. Next slide, coming to the analysis strategies. So here we are dealing with parametrizations of the data and also with the scheduling of the observations, or also the background models used in the data processing. We have studies which recommend definitely harmonized parametrization across all space geodetic techniques. What I mean with that is, if you combine the data, for example, at the level of normal equations, it is really important to parameterize the different geodetic parameters like Earth orientation parameters in the same way. Usually the services provide data where they, for example, don't set up the parameter for delta UT1, for satellite laser ranging due to the reason that SLR alone as a satellite technique is not sensitive to it. But once I start combining this with VLBI, it would be really important to have this parameter in all techniques in order to estimate consistent combined parameters. Another point is the scheduling of observations. On the one hand, we have multiple studies for VLBI who are dealing with the setup of the different sessions. On the other hand, there is also a publication which raises the question at which time to perform these sessions. For example, should the 24-hour VLBI sessions be adapted to the UTC day in order to have a symmetric data distribution around the epoch of the parameter we want to estimate? For example, Earth's rotation parameters at noon. And apart from this is the last block here. Of course, it was shown multiple times that data analysis also has to rely on precise and consistent geophysical background models. For example, if I'm estimating delta UT1 from VLBI intensives, I have to have accurate a priori values for the other parameters to which intensives are not sensitive. Okay. Another point of analysis strategies is the application of tropospheric ties. It's just an example. So we have different microwave-based techniques who basically have the same sensitivity to the troposphere, but so far are processed independently from each other. So the technique processing is done at the different services, and then later on, for example, the estimated parameters are combined. Whereas you could directly process these techniques together or in the combination apply, for example, the tie in that way that you know the atmospheric parameters must be the same for both techniques. And as we can see on the right-hand side in this plot, this significantly, for example, can improve. So the violet bar is with applying tropospheric tie. It significantly improves the quality of the Earth rotation parameters, for example, that we can estimate from VLBI and GNSS. Of course, what is nice here is if you apply tropospheric ties, a technique with a smaller number of observations can benefit a lot from a technique with more observations, which of course then is more sensitive to these tropospheric parameters. So now my last slide, just to show you that we are not just doing this for nothing. There is a big amount of projects who are relying on results from studies like this. And I now picked out one example of this in which I was involved until recently. It's a research unit established by the DFG, the German Research Foundation. It was initiated by Ulrich Schreiber from Kehm. And it is a multidisciplinary, let's say, group of projects which aims to replace the classic combination of space geodetic techniques via local ties by a quasi-error-free combination based on a common target and common clock at a co-located site. The testbed is Männel for this. Some infrastructure has already been established. And within that framework, for example, various simulation studies are being performed in order to try to achieve these goals. And they rely also on results we have produced so far within the framework of PLATO. Yeah. And with that, I'm handing over to Benjamin.
Thanks. Okay, so I will report about, let's say, the activities or simulations studies on collocation in space, and with this small picture we see already that collocation in space can be done usually, let's say, at the level of LEOs, low orbiters, or somehow above, and collocation on board of GNSS satellites. I tried to sort that a bit here. So red are real data. Of course, we have the GNSS constellations available. We have various Earth observation missions, the Sentinel-Jason Swarm or gravity missions, where we have multi techniques. For simulations, we have seen in the past for GNSS-like or GNSS-based VLBI studies, or this investigation on the third generation of Galileo satellites. And of course, on the LEO side, we have seen GRASS, eGRASS, Genesis, all those missions, which were mentioned already by Johannes in the previous talk. Yeah, in terms of the techniques, in red, GNSS SLR or some of the GNSS satellites, GNSS SLR and DORIS on the LEO side, and of course, various simulation studies added then VLBI on both sides. And in black, I added here a bit about, let's say, technology developments. So we have to deal with orbit combination with space-based GNSS and with satellite tracking for VLBI. And I'd like to focus here a bit on the various activities now. In terms of the VLBI satellite tracking, the first thing is, of course, the near-field delay model, which is needed to cover the curved wavefronts. And yeah, a couple of models have been published over the last year. So there is development, which is, of course, necessary. If we look then into the observations, so single frequency GNSS observations have been performed in a couple of R&D sessions. So, for example, tracking GLONASS L1 signal with VLBI, or recently the NAVIC S-band signal. Yeah, technology demonstrator, the APOD satellite, the XS beacon, and of course, various simulation studies. Yeah, the outcome of those studies, of course, we need a careful scheduling of the satellite and the quasar observations. So this is really the essential task. And what was mentioned also by Johannes, we can, of course, try to go for a time-encoded signal, which would be very helpful compared to a noise-based transmitter. And mentioned already investigations towards the VLBI transmitter at the Galileo satellites. In terms of the space-based GNSS, which is of course important, as for the LEO, we have the GNSS as a receiver in space. We need to think about consistent processing. So either one common approach where we put all the observations in one least squares, or if we prefer the next stacking, then we have to keep the satellite clock parameters in the normal equations, which is of course a bit challenging in terms of the number of parameters. Improvement for the geocenter have been shown, where the LEOs in that case provide a bit more sensitivity, a bit more geometry, and also absence of troposphere in the observations. Then investigations on the GNSS transmitter offsets have been shown, where we can make use of a gravitational constraining. So the LEO orbit is independent from the terrestrial scale, and with that we can estimate the transmitter offsets and the terrestrial scale if we combine in ground and space GNSS observations. And we have seen various simulation studies covering the impact of synchronized clocks into satellite links, and also antenna design for receivers in a higher orbit. And if we go then to the 4 techniques and related simulations, this is kind of a repetition what we have seen in the presentation of Johannes. So GRASS, eGRASS simulations, and of course the way to reach the GGOS goals with those missions or mission proposals. Then simulations related to the 3rd generation of Galileo satellites, with the inclusion of a small LEO constellation and intersatellite links, showing, of course, then also significant improvements for the geodetic parameters. LEO PNT is a big topic for navigation. Not yet, let's say, for Geodesy. Might be also interesting to investigate the impact of huge constellations of lower orbiters. And just to mention that here, because it was a entire presentation on gravity emissions and the related simulations. And I would like to end with this slide, which is not very detailed because there was a presentation beforehand on the Genesis mission. So most of the investigation simulations, which I tried to summarize, and it's not complete over the last slide, they are needed then for the Genesis mission to fully exploit the mission. And as we have seen in the previous presentation, there are ESA working groups, there's an IAG working group, and also PLATO is kind of in that game. And of course, we close interact within those components. And that's it. If you have questions.
Any questions? Donate online. You do have one.
Yeah, I have.
We have minus 10 minutes for questions.
One of the main, how should I say? One of the main, is it's always said that GGOS and IAG don't own the geodetic infrastructure, and therefore it's very difficult for us to set up goals in order to improve the infrastructure. And it's true, GGOS and the IAG are not able to install a geodetic fundamental observatory. We don't have money to buy a VLBI antenna or SLR telescope, and we don't have money to launch a new satellite mission, but we are able to provide scientific foundation for policy decisions in this direction. Somewhere in the future, the United Nations says we have $200 million for geodetic infrastructure. PLATO can say where this station should be installed. Or in, I don't know, 10 years, it's allowed to dream. ESA or NASA said we want to make a constellation of Genesis satellites. PLATO can say how these satellites should be built. So I think this work is important, although we don't have money and although we work on a basis effort. So that's all.
Yeah, so thank you, Laura. Yeah, we are always, of course, as part of the BNO, in close contact with Jose. I think it's the plan to come up at some point with like a concise summary of recommendations, to have something at hand. If there would be somebody interested who has money to spend, there's something to come, I guess.
That's right. I was going to ask you to mention it. So the result of this, so this was a presentation, as you said, a preview, but we talked in April that it would be a great idea to have take a stock of the situation. There have been loads of papers on this. Okay, what do we know? What do we do not know? And where are the gaps? And let's take it from there. Thank you very much.
There's another question.
Lucia, please. We cannot hear you yet. Not yet.
No, still not. Well,
No,
then.
yes. Please go
Yes.
ahead.
Difficult question. As a network station, we continuously have to request how important are your stations, or whenever some country tries to build a new station. But the first approach is they have to find somebody who runs simulations for them of the
The host.
Oh, yeah. Okay.
I think you lost connection.
I think we can.
and the simulation.
Lucia, we lost you for 20
whatever.
seconds.
I put in a station and it gives me some parameters how important it is.
I think.
Yeah, okay.
Because,
And maybe she can write me an email.
Yeah, well, yes, we write it. I write something there. I think we kind of know where she was going, though. Do you want to have a guess at what the question was and answer it?
Yeah, I guess.
Because I think we know.
Yeah, in principle, it's about the motivation to operate such stations.
Correct.
Yeah, as I said, we have done some studies on existing stations, or at that time not yet existing stations, where we could demonstrate the importance. So in general, yeah, we have some papers at hand for this, of course not for any specific site, but it's something one can do in cooperation with the groups who perform these simulations. Also to motivate, like improving the site technically, to have more performance, to exploit all the time, you could perform measurements, for example, by automating systems.
Are you saying if somebody came to you and said, hey, and I have a quick job here, I want to know how much worth my station is in terms of the contribution to the global reference frame, is that something that could be considered?
So it's something one can consider. Of course, it's not so easy because the stations work all together. So we have a network. You cannot say a single station has a certain value or it doesn't have it. I mean, we need more stations. We can give recommendations where to build new stations. We can motivate improving stations technically. Yeah, but you cannot say it has exactly this or that value. So it's more of the value of the network as a whole, I would say. But
okay.
Maybe I can add. This is of course a question which is related, let's say, to performance, but of course it's also a question which is related to the data outcome. And there we are not only on the performance aspect, but also, let's say, what you mentioned beforehand, in terms of citation, so that we give a value to the data which are achieved. But of course, this is something which is not directly related to PLATO.
A small comment also from my side. Even today in the morning, I had a really small discussion. You know, there's the overall goals. It has been also mentioned several times. The day in the morning, the GGOS, the accuracy 1 millimeter with a 0.1 millimeter per year. What we would like to achieve, but you know, if you are going to the decision makers, they are even willing to help you. It is so complex, you cannot get straightforward, and you see all the small elements which improve it, like a genesis or whatever, you know. And this is so complex. It is very important. It's very difficult to go to the decision makers and say, okay, we need this because this has this value. Because as you say, this is so complex, and we are used to geodesists are very, how to say it, very clever people because they know there can be some failure or old age and they have to deliver on daily basis, you know. And what we need for the decision makers is really clear list of simple arguments. For example, we need this one and what that is for value. And this will be even if it is complex, to simplify this is very, very important. And this is what we need at the center. Thank you.
In cooperation.
If you want to say something quickly,
very quickly. So I think it would be nice to have like inventory of the parameters we want to estimate, and then we can relate certain locations of stations to these parameters. As I said, you can differentiate between the purpose you want to determine, and then you can maybe like argue why the station is important at this location because it contributes to exactly this and that parameter.
Okay, yeah, instead of a one by one. Okay, thank you very much.